Hello everyone, hi and welcome back to our machine learning series. In the last video, we learned how to split our data set and choose the best feature. Remember that? Well, in today's video, we are taking the next big step. We will dive into the second step of building a decision tree, which is all about iterating and improving our model step by step. We will go through a complete decision tree walkthrough, understand the final decision rules, and most importantly, see why we need stopping conditions. Because, yes, even trees need to know when to stop growing. So, get ready. This is going to make your understanding of decision trees crystal clear. Let's begin. Alright, friends, let's move to the second step of building our decision tree, iterating. So after we choose the best feature to split our data, maybe using accuracy, GiniIndex or entropy, the decision tree doesn't stop there. It keeps repeating the same process again and again, but this time on each smaller part of the data. For example, in our case, the best feature for the first split was age. So our data set got divided into two smaller groups, one for young users and one for adults. Now each of these smaller groups will again be checked to find their own best feature to split on, maybe device type or app preference. This cycle continues, split, check and split again until every group becomes pure, meaning all this data inside it belongs to one label only. So the key idea is our decision tree grows step by step by repeating the best split on every new subset until the data is fully classified. That's what we call iteration. The tree keeps learning from smaller and smaller pieces until it understands everything clearly. Alright, now that we have understood how iteration works, let's actually walk through an example to see how a decision tree grows step by step. Start with the dataset. Here's our small dataset of app users. We have three columns: platform, age group and app, which is our label or target. Now our goal is to build a tree that can predict which app a person will use based on their age and platform. Step 1. Split on age, root node. The first thing we do is find the best feature to split the data, and in this case it's age. So we divide our data set into two groups, young and adult. For the young group, rows 1, 5, 6. Labels fit tracker, fit tracker, fit tracker, all are the same. This means the young group is perfectly pure. Accuracy is 100%, Gini is 0 and entropy is 0. So this becomes a leaf node. Prediction fit tracker A. For the adult group, rows 2, 3, 4. Labels code champ, pet pearl, code champ. Here we have two code champs and one pet pearl. This group is impure, so we will need to split it further. As you can see, the tree first asks, is the person young? If yes, all go to fit tracker. If no, we still have mix, so we will need another split. Step 2. Split the adult subset. Now we only have one feature left to check, platform. Let's split the adult group by platform. For iPhone, both are code champ. For Android, pet pearl. Perfect. Both sides are now pure. Our decision tree is complete. Here's the final decision tree. It first check the age. If the person is young, we predict fit tracker. If the person is adult, then it checks the platform. If it's iPhone, code champ. If it's Android, pet pearl. So this is how the tree keeps splitting one step at a time until every path leads to a clear prediction. That's what we mean by iterating and growing a decision tree. Okay, we have built the tree and now let's state the final decision rules. Plain and simple. Here are the rules we will use to make a prediction for any new user. Rule 1. Check age first. If age is young, predict fit tracker. This is because every young example in the training set used fit tracker, so the tree makes a leaf here. Rule 2. If not young, then age equals adult. Check platform. If platform iPhone, then predict code champ. If platform Android, then predict pet pearl. So the summarized rules are: pick the best feature to split the data. We picked age first. Split the data set by that feature, young versus adult. Check child purity. If a child subset is pure, all labels same, make it a leaf and stop for that branch. If it's impure, repeat with remaining features. We then split adult by platform. Repeat until all branches are pure or stopping conditions are met. In our example, the process finished the tree, age, then platform perfectly classifies the training set, and that's it. 3 simple rules that the tree uses to make predictions. Next, we will talk about why we sometimes stop early even if a branch is not fully pure. Stopping conditions. Alright friends, we have learned how to build a decision tree and the final rules, but here's an important question. Why don't we just keep splitting until every leaf is pure? The answer is overfitting. If we keep splitting until every leaf is 100% pure, the tree may create many tiny leaves that are too specific to the training data. This makes the tree really good at memorizing the training set, but it may perform poorly on new unseen data. That's why we need stopping conditions. They prevent excessive splitting and keep the model simple and generalizable. 4 common stopping conditions. First, threshold for improvement. Don't split a node if the change in accuracy, GiniIndex, or entropy is below a certain limit. Basically, if splitting won't improve the node much, we stop. Minimum number of sample per node. Don't split a node if it has fewer than a specified number of samples. Small nodes are not reliable, so we leave them as leaves. Minimum number of samples in child nodes. Split a node only if both resulting leaves have at least a certain number of samples. This prevents creating tiny unstable leaves. Maximum tree depth. Stop building the tree after reaching a certain depth. This ensures the tree doesn't grow too tall and complicated. In short, stopping conditions help us control the complexity of the tree, prevent overfitting, and make the model generalize better to new data. And with that, we have completed the full walkthrough of building a decision tree, from selecting features, iterating, understanding the final rules, to knowing when to stop. And that's it for today's video on decision trees. Thank you so much for watching. If you enjoyed this tutorial, make sure to stay connected. Follow for more videos on machine learning and data science. I would love to hear from you too. Drop your thoughts, questions, and suggestions in the comments or notes below. I always read them and try to reply. Until next time, keep learning and experimenting. See you in the next video. Bye bye.